A very good morning to you. I'm Daryl Brugink, Executive Editor with No-Till Farmer, and I'd like to welcome you to today's webinar, where we're going to learn about how you might reclaim some troubled fields. Now, more specifically, we're going to look at some of the things you can do to jumpstart a field that has perhaps been abused or maybe just depleted of some good soil biological activity, all in an effort to make it more productive. Today's No-Till Farmer webinar is sponsored by Midwest Biotech, and here to help us learn more about taking steps toward better soil productivity is Doug Miller, Vice President of Midwest Biotech. And Doug has done a number of webinars on varying soil health related topics, and he's done some teaching in his past, so we know he always does a great job of presenting. And we look forward to hearing from Doug in just a moment. Before we turn things over to Doug, there are a couple of items we want to make you aware of. On your screen, you're going to see a box. There's an orange box with a white arrow inside of it, and you can click on that to open up a question field, a comment field, and you can submit any questions at any time during the presentation. And at the end of Doug's presentation, we're going to look to answer as many of those questions as possible. If for any reason you find that the webinar is disrupted or you seemingly are disconnected from the webinar, just go back to that invitation email you received and rejoin the webinar through the web link in the email. So with that said, we want to thank you again for joining us, and we're going to turn over the controls to Doug. And he made the drive up from Erie, Illinois to our Milwaukee offices today, and is with myself and producer Cole Vandermouse here in the offices. So good morning to you, Doug. So thanks for being here in person.
My pleasure, Daryl. It's always good to be with you and Cole and the folks at Lessiter, and especially if we have a chance to talk a little bit about soil health. So this is our fourth webinar. All of the past ones have gone well, and we wanted to do this one to kind of build on the topics that we've discussed in the past. And in particular, what we'd like to do is report the results of a 3-year study that we've conducted actually near our location in northern Illinois. And I think it really highlights the potential for change that you can make in a troubled field by increasing biological activity. There are lots of ways to do that. A lot of fields are different, have different sorts of problems. We'll describe what was going on here. But I think whether you're using reduced tillage practices, cover crops, rotations, manures, or biological additives like we're in the business of marketing, anything that help improve the soil biological activity can help resolve some problems. Not everything, but I think what we'll talk about today kind of highlights the potential for change that you can make. Not immediately, doesn't occur overnight. Biology moves slow in some cases, but you can make some steady changes and improvements. And that's what we wanted to describe, kind of building on the things we've talked about in the past through our earlier webinars. For example, the one we did, our first one was 2 years ago. We were together almost exactly 25 months to the day. I look back and we talked about the different types of biological additives. We're about enzymes. There are the companies that market live microbe products, humates, things like that. They've got their different pros and cons. We don't want to cover that same material, but we do want to build on that by showing what's possible by trying to improve soil health, whether you're using a biological additive or some of the other cultural practices that farmers have available. Main thing is that there are multiple tools in the kit, and sometimes you have to use more than one to overcome some of the problems. So what I'd like to do to start is just talk a little bit about our goals. And the general direction we're heading is of course, soil health. That's a very hard concept to define. I've heard people better than I debate, what do we mean by soil health? And I guess by analogy, we could think about human health. A person who's physiologically capable, alert, well-rested, might be healthy from a baseball manager's perspective. Hey, here's a guy that's ready to play the game today, but maybe they got a rash on their arm. That's not going to affect their play, but are they healthy in all dimensions? So really what we're talking about, I think, in terms of soil health is productivity. Are there problems that are going to affect the productivity of a particular soil and cause problems either with growth, nutrient availability, drainage, all of those sorts of things that are going to help crops grow, thrive, and survive and produce yield. Um, there are better people than me to define what soil health is. It's almost one of those concepts that's easier to say what it's not. When we have particular problems that are going to affect productivity of a soil, if it's not porous, it doesn't drain well. Air and water don't move well because there's poor soil colloid formation. We've got low organic matter. Uh, it may have plenty of nutrients, but they're not available because there's limited microbial activity, or there are other problems in the soil. Um, Anything that affects the productivity of that soil is going to lead to a soil health problem. It's important to understand what the causes are of those particular problems. If you're having productivity issues, or you're having drainage issues, or you've got limited nutrients, because there are many different things. There's no one blanket approach where you've got one cause and one treatment. A lot of people are saying, hey, what's the best way to resolve a productivity problem? And I think what we'll show today is that you really have to understand the underlying causes before you consider a treatment or a method. And in a lot of cases, what we're probably going to be looking at is having more than one approach to resolving any particular problem. But once you get a soil that's biologically active, quote unquote healthy, doesn't have a lot of the problems that are going to affect productivity, you've got good soil structures. We see on the right that sort of styrofoam type appearance of the soil, where you've got lots of little colloids formed, nice structure. You've got potentially earthworms, mushrooms, biological activity that's evident. The soil should drain well, adequate fertility, and it's going to be as productive as you want. But that's the goal. Again, somebody better than me is going to have to define soil health, but I think in terms of troubled fields where we find problems, it's the matter of trying to resolve those by improving, in particular, from our perspective, the biological activity that can be hampered by poor drainage, nutrient imbalances, and other things. Anybody who's familiar with the Lessiter publications, Conservation Tillage Guide, the No-Till newsletter, Strip Till publications, if you've been to the conferences, you've had plenty of exposure to all of the ideas that are commonly used, the standard methods to improving soil health. Reduced tillage, number one. It's very attractive now for economic reasons. Less capital required, less fuel, less power, fewer trips across the field. Tillage burns up humus, so you're going to help preserve some of your permanent soil carbon. It's going to build those microbial populations, especially your fungal species, which are sensitive to tillage, will be less disturbed. Fewer problems with disturbing earthworms and some more of those macro species that help with nutrient availability and building soil structure. So there are a lot of advantages to reducing tillage. But I've also heard from a lot of people that either have experienced problems with no-till approaches, so they try strip till. I've talked to other people that say neither one of those will work on their farm. Their soils are too heavy, their climate's too cold, for whatever reason. But we know that there are other approaches. Cover crops, very, very hot topic right now, as we've been discussing. Again, when I was in college, long time ago, they told us that it's a way to conserve nutrients. You're going to pick up excess nitrogen, other nutrients before they're leached out of the soil. So it's a way of protecting those resources. Of course, you're going to provide surface cover, less wind, less water erosion. Those were the things they were talking about years ago. Recently, we've become more in tune to the microbial relationship between root growth and the root exudates, the compounds that the roots seep or release, and serve as a source of food and energy for the microbial population. So you hear more discussion about that. That wasn't probably appreciated as much years ago, but we've become more in tune with it. Cover crops have their cons as well. You take a year like this past year where it was a late harvest, it was wet, it was cool. A lot of people had trouble establishing cover crops. Even if they got them out there, they didn't develop much cover. Hopefully you got better root development, because that's really where most of the benefit is. But driving around the Midwest, you see a lot of cover crops that got off to a late start, didn't establish much cover. They're pretty thin, relatively low germination. And so cover crops don't always work if you get into a late harvest year. It's especially dry or wet or cool where you're at. Now, I'm not an expert on cover crops. I know some folks had questions about using cover crops to restore soils. I'm probably not the best person to ask, but just in general, it's another tool in the kit to help restore those microbial populations, preserve nutrients, and protect the soil from erosion. If you've got trouble in a field, that could be helped by improving soil health by increasing microbial activity. Beyond that, we've got the crop rotation issue. The con of that is typically the economics. So in some areas, you almost have to be continuous corn in order to make your rent payments on your land, or justify the investment, because that's just the way the price signals are. But if you can, either a corn bean rotation, or better yet, mixing in some rye or some small grains can help. Cover crops are part of that. By planting a greater diversity of crops, you also support a greater diversity of microbes, because different root systems, different crops encourage broader growth among the microbial populations, and it also helps with nutrient management, using things like legumes, soybeans, other crops, generate some nitrogen, and that can help with your nutrient management program. And of course, it's a little bit less common to hear people talk about using manure due to concentration in the livestock industry, but if you're in an area where that's available, that's another tool in the kit. You not only can provide some nitrogen or other nutrients, but help, depending on the nature of the manure, might provide some source of carbon to help build organic matter and things. So those are the standard approaches to improving soil health. And again, the publications that Lessiter produces and the conferences have been full of information about all of these different approaches, and lots of people much better than I on how to use these tools, and when to terminate cover crops, which one to use, how do you manage them in northern climates, all those sorts of questions. I wanted to stay away from that, because that's not really our strength. We did want to talk about using biological products in addition to these other tools, or as a complement to them. For example, our product, Chandler Soil, is an enzyme-based soil treatment. Unlike most of the other biologicals on the market that have live microbes in them, live cultures where you're actually adding the living organisms back into the soil, what we do is multiply the microbes that are already present in your soil. The pro of that is that it tends to work relatively well across different soil types, different soil chemistry, pH levels. If your soil is really depleted of biological life, it can be a slower start than adding live microbes. The live microbe approach would work well if they've been cultured in an environment similar to your soil chemistry, but if there's a compatibility issue, either the pH is off, maybe there's a compatibility issue between the cultured microbes and the ones that are native to your soil, the live microbe approach may not work as well. There are humate approaches and other things. We talked about those 2 years ago in that first webinar that we did. We don't want to retake the same ground, but our approach is just another tool in the kit. Let's multiply those microbes by using cover crops, by reducing tillage, by using manures if they're available, rotating the crops, and also trying to multiply them by using products that are intended to help support those populations, feed and multiply the colonies that are present in your soil. We also provide some chelated micronutrients. Those help with forming other key enzymes in the soil that help regulate the growth and multiplication of the microbial populations. It's not there for fertility purposes, but it's there for enzyme formation purposes. And we also have a surfactant, so that even if you're in a no-till situation, You can apply the product on the soil surface, and the surfactant helps take it down into the soil, so it does not have to be incorporated, disked in, plowed in, etc. As long as it's applied to the surface, the enzymes and the other ingredients will get down where they're going to work. So again, just another tool in the kit, and in talking with a lot of people that have tried to improve their soil biology and resolve some soil health problems, typically it's going to take more than one of these tools to work. A combination of reducing tillage and cover crops, introducing some rotations, using a biological product like ours or somebody else's. So that this isn't a sales presentation for Chandler Soil necessarily, but what we'd like to do is talk in terms of our experience, and this is what we've got the most experience with. But the end result is we're all trying to improve biological activity in the soil to help resolve some of these problems we might have with drainage or porosity or organic matter that might be low, or compaction or nutrient problems. And it's one way you can attack those problems by improving the performance of the soil. Just to illustrate what's possible with Chandler soil, by not adding live microbes but by multiplying what's there, you not only affect the soil bacteria, which are very important for soil structure formation and nutrient availability. It's also very important in legume crops because those bacterial colonies help form the nodules and the nitrogen fixation. But by using a biological product that helps to multiply those colonies, you can affect not only the bacteria but the other microbes as well. It's sort of a broad spectrum approach. We're not just adding a few species of bacteria or fungus or something else, but we're multiplying all the guys that are out in your field. Just to illustrate, this graph is taken from one of the early university studies that was done way back in the early years. This was at a school in Louisiana, proprietary research that was done in an actual soybean field. It's not a lab or a greenhouse result, but it was actually in an actual soybean field. Field was treated with Chandler soil in May, and then the researchers followed on a monthly basis the log colony counts in the treated and untreated side of the field, and then they did so on a monthly basis through the end of the season. And so as you can see, the red line is the growth of the bacterial counts in the soil as you move from May to October. Generally, as the season warms and you've got more activity from crop growth, the soybean growth in the field, you'll get more bacteria because the roots and the warmth, the moisture that's available are all going to support the growth of those colonies. By multiplying their activity through the enzymes, the colonies in the green line, the treated areas, were larger in number. And by October, this is a log scale, and it's a multiple. So this scale shows there's a 0.3 difference, and actually that's on 1,000 log scale with that. So that means roughly there were 300 times as many microbes, soil bacteria of all types, in the treated side than in the untreated side. And so the growth not only started relatively slow, but it did build over the season and continued to grow into October. So this is one piece of evidence we show that biological products intended to help support the reproduction and growth of these colonies can have an impact across the entire season. Actinomycetes, which are important for nutrient availability, especially for residue breakdown, product also is effective on them. The log colony count was pretty stable across the entire growing season. It jumped June to July, but then stayed fairly stable after that. But the increase in the treated part of the field was pretty substantial, especially middle of the summer. It did tail off as things cooled September to October. But basically what we're talking about is about a 10-fold increase over the untreated part of the field middle of the season, and about a 3 to 4-fold increase early and late. and then the fungal species, which are very important, especially for residue breakdown, nutrient availability. And there's some evidence that the soil fungus help the plants to communicate about pest issues and insect infestations and things. The fungal species are slow to develop. They take longer to develop than a lot of the bacterial species. So you don't see much of an increase until later in the season, but it does build on itself. And by the end of the season, you've got about a tenfold increase in the treated area relative to the untreated area. So whether you're using cover crops, manures, rotations, reducing tillage, or biological additives, they're all intended to help support these populations, whether it's bacteria, actinomycetes, algae, earthworms, macro and micro species, and make the good things happen in the field that we're looking for. So that's our approach. And again, we're not strictly making this a sales job on Chandler soil, but trying to show what can happen in a farm field that has some trouble. The example I'd like to use is a field that is a bit south of us in Henry County, Illinois. It's a clay to clay loam soil. It's not really a heavy clay. The cation exchange capacities run from the high 20s to the low 30s, so it's not a high CEC soil. It should be relatively well drained and productive based on other fields in the area, but this particular field has a lot of issues, and most of it comes from being over-limed with high magnesium lime. And one of the things I'd like to highlight today is that there's not one common reason why soils become compacted, poorly drained, and unproductive. There are many, and it's important to understand where the problem started so you can help to try to resolve it. This particular field changed hands in 2011. The new landowner was somebody we've known for a long time. They're very familiar with what we do, and said, I want you to help me resolve the problems on this farm. And so we said, okay, we'd like to set out some test strips and do some experiments. And the landowner said, no, I want to get the whole thing fixed. So what we have is basically we treated the entire field, and followed it beginning in 2011 for the last 3 years. The study's going to continue, but what we'd like to do is talk about the results we've had from the first 3 years. The field looks really nice. It's a square quarter section, nice 160 acre field. It's more or less level. If you've ever driven from Iowa into Illinois on Interstate 80 and you leave the Quad Cities heading east towards Chicago, the very first town you come to is Geneseo. This field is a few miles north and east of town, so it's well located. The topology is really good. Sited on two sides by roads. Neighboring fields are very productive. It just turns out that this one over the years was over-limed with the local lime source, which is high in magnesium. And what happens when you get magnesium in soil is the magnesium is essential for forming chlorophyll. And so if you're short on mag, you'll have low chlorophyll formation, photosynthesis won't operate properly, and that's going to hurt yields. So you need magnesium, but once you get too much, it's a strong cation. It's got a double plus charge. It binds to clay very tightly, and basically that's going to tighten up that soil and make it less porous, less well drained, and as a result, it's going to hurt the production over time. As you add additional lime, the additional magnesium is going to tie up the other nutrients and say, hey, you need more calcium. And so the soil tests over time were calling for more and more lime. The previous operator had done that based on the soil test, and by adding more and more magnesium, you actually make the situation worse. And so when we started, this soil was almost like walking across concrete. It had a lot of surface water set on it even after modest rains, And so the landowner, when they got a hold of this property in 2011, said, I'm very sure you can solve the problem for us. They were familiar with what we'd done in the past and said, let's fix it. So we decided that, this is a study that came to us. It wasn't one that we sought out. We do a lot of our own testing on private research farms and side-by-side tests in farm fields. This one elected us. And so we decided we'd work with the landowner. And what we did was applied fall and spring our regular treatment of Chandler soil, 16 ounces per acre. Normally you just need one treatment per year, and that's what we recommend to everybody. But because this field was in such bad shape, so poorly drained and highly compacted, that we wanted to see if we couldn't jumpstart it a bit. So we applied 16 ounces of soil broadcast in the spring across the entire 160 acres. Came back in the fall and did the same thing. We also added our residue digester, BioCat 1000, to help with residue breakdown. That's one of the problems you see in a high mag soil, is that the magnesium actually helps convert the sugars in corn stalks as they decay, not to sugars that the microbes can use, but to alcohol, which further degrades the microbial population. So you tend to see poor residue decay in high mag soils. And so we wanted to help resolve that. So we did add our biological residue product in the fall treatments, and then treated it twice a year starting in June 2011. And we took our last set of measurements last October, beginning in this past year. So it was just over 3 years of time that we spent working with this field. And again, we're going to continue to follow it, but the results we've seen to this point are pretty encouraging. And again, I'm not saying that our approach to the problem is the only one. Anything that would have encouraged biological activity on this field would probably have had very similar results. The land's not operated by the owner. It's in a tenant situation, so you can't do much with reducing tillage. They weren't interested in cover crops. There's not manure available. This field was probably applied with manure 30 years or more ago, but not now. It is rotated. It's usually in a 3 years of corn, 1 year of soybean rotation. So that does help a little bit, but some of the other tools that you would normally use weren't available, and our goal was to try to reduce the magnesium content by opening up the soil structure through increasing the microbial activity. Once you start to build the soil structure, allow air and water to penetrate, move within the soil, reduce the compaction, then you can start to leach the magnesium out. The standard treatment for a high mag soil is you bomb it with calcium and sulfur. The calcium flocculates the soil or opens up pore space, and then the sulfur interacts with the magnesium to acidify it and leach it out of the soil, and that's how you get rid of it. But when a soil is so heavily compacted, it's sort of like having a plug in the bathtub. You can't drain the stuff out you want to get rid of until you get that plug out and you can open up the structure. So based on our previous experience on many different farm fields, we thought anything that would help the microbial activity to build that soil structure, reduce the compaction, would then help the sulfur in the soil to acidify the mag, leach that out, and then that would help resolve some of the trouble in this particular field. So that was what was specifically going on in this particular case. We've worked with lots of others, and again, I want to emphasize that the key thing when working with a troubled field is understanding the source of the problem. You can't just throw a one-size-fits-all approach to every situation. If depending on your location, the soil type, and things like that, cover crops may not always be the best option. Biologicals of one type or another may not be your best option. You may not be able to reduce tillage, but maybe you can go to a strip till system or something like that. So you have to figure out which tools in the kit can you use. Use as many as you can. but try to understand the problem as well as you can before you start treating it, and not taking just a one-size-fits-all approach to it. What we saw when we started in 2011, in June of that year, we made our first treatments, and we took soil penetrometer readings to measure the degree of compaction. A soil penetrometer is a stainless steel probe. Ours is 27 inches long. It's made by Dickie John. And at the end of the probe, down at the bottom, there's the tip is connected to a dial on the other end. And the dial measures how much resistance the tip is facing as you push it into the soil profile. The readings are measured in pounds per square inch, and the agronomists have helped us determine how to read those pressure readings as we take them in the field. And what we found starting out was that the average amount of uncompacted soil in that field was about 4 inches. So as you shove the penetrometer into the soil, the resistance increases, and we take the measurement when the penetrometer reaches the 200 pound per square inch level. Based on the calibrations we've seen, at about 100 pounds per square inch of resistance, 1/3 of the roots for most crops would be impeded from growing any further through that soil layer. At 200 pounds per square inch, about 2/3 of roots are going to be impeded from any further growth. And at about 300 pounds per square inch or more, you start to see almost all the roots are going to be impeded. So some folks, when they use penetrometer readings, go to 300 and say, well, the soil's so compacted at that point, it stops almost all root growth. So they use that measurement. We stop at 200 because 2/3 of the roots can't grow. That's pretty serious impact, or should have a serious impact on soil productivity and potential yield. So what we do is stop the probe when it reaches 200, measure that depth, and then that measures how much soil is uncompacted at that. And then we took at least 15 recordings. Southwest corner of the field is a fairly heavy clay. It's poorly drained. It was the worst part of the field. Then we went to the northwest side, which was the same sort of clay. It's just a little bit higher, so it has a little better surface drainage. East side of the field is a clay loam, a little bit better drained, but still fairly compacted. As we found, we didn't see much difference from different parts of the field in the readings. That first year, we had readings between 3 to 6 inches of uncompacted soil. The average was 4, and so that's what we're reporting here. We tell folks that if you activate your soil biology, whether you're using our product, somebody else's, any of the other tools for improving soil health, that you should expect to see about 6 inches of improvement in the degree of compacted soil each year. Now, this field, since it was in such a bad shape, we didn't do that well the first year. We saw a 4-inch improvement. So 2012, September, we went out, took measurements. The average was 8 inches of uncompacted soil. We had gained 4 inches of root zone. We did dig plants each year. We noticed that the roots were able to penetrate more deeply. Tap roots were able to go down without less trouble. There was less massing of the roots near the surface. They were able to penetrate the soil. 2012, we gained 4 inches. 2013, things started to accelerate. We gained 7 inches, a little better than average. And then last year, 2013 to 2014, we gained 12 inches. And in fact, every one of the 15 locations we tested last fall had a full 27 inches of uncompacted soil. There were no short readings. Every location was full probe depth. And I should note that it's important to account for moisture levels in the soil. If you try to do this with dry soil, you're not going to get much penetration. You're going to get bad readings because the soil's hard at that point. If you're working with a muddy or saturated soil, you're going to get bad readings because the probe will go in much easier than it should. So you have to make sure that the soil is moist, but not too damp or too dry. So we always tried to wait until after about an inch rain or better, and then go out 2, maybe 3 days after that. So we could get roughly the same moisture content at every time we took these readings in order to control for that moisture difference. Um, in time, it took 3 years, but we have more or less opened up that soil structure. And now that the plug's out of the bathtub, you can start to drain out the unwanted magnesium and rebalance the soil and resolve some of the trouble we've got with this particular field. The magnesium content was so high that when we would walk out of the field after taking these measurements, you'd have about 2 inches of mud crusted around your boots and on all sides. And it'd take you 10 or 15 minutes just to scrape the mud off. And if you let it set, you'd almost have to chisel it off when it was dry because it was that tightly bound to the clay. It was a very sticky, gummy situation, and the tenant had commented about the trouble he'd had with, he was running a chisel plow. It's not a no-till operation, and some of the issues he had with tillage in the field because of the stickiness. But that's resolved for the most part. The soil is draining much better. You don't see pooling of water even after pretty good rains. Water is able to penetrate down into the soil, and so that part of the problem has been resolved. In terms of the soil tests, we took soil tests in 2012 and 2014. The benchmark, again, 2012 was about a year after we started working with it. Given the slow start, it's probably indicative of what we had when we started in 2011, but the issue that was really causing the problem was this high magnesium. If you look at the base saturation numbers for 2012, on the west side of the field, the clay side, you had almost 37% magnesium, 60% calcium. You add those two together, and according to the experts, they shouldn't be much over 80. We had almost 97% magnesium calcium. The calcium was okay. You're supposed to have readings somewhere in the 60 to upper 60 range. So we had adequate calcium. It was just the magnesium was way too high. You're looking for a number closer to about 12 to 20. And we had 3 times that much because of this local lime problem and the fact that it had been over-limed with high mag lime. East side of the field wasn't quite as bad since that was a clay loam. We had about the same amount of calcium to start, 62% in this case. The mag was almost 30, and the base saturations of those two were over 90. So that's where the problem was at. Too much magnesium, the soil was too tight, could not drain, could not decay residue, very sticky, and limited microbial activity. 2 years later, this past fall, we went out and took another set of soil tests, sent them to the same lab. They were taken in the same locations at the same depths. We didn't take but one. We took a group of them, mixed the soil together, so you got a composite reading. And in this case, the mag, after opening up that soil structure, resolving the compaction problem, getting the water to flow out, the magnesium had dropped down to about 25. It's still not quite where we want it yet. We'd like something under 20, but it's headed in the right direction. The calcium has dropped because as you leach out the mag, you're going to lose some calcium. The sulfur numbers, which I haven't provided here, were adequate to start. They're now getting a little bit low because it's the sulfur that helps acidify the magnesium, and then once it's acidified, it'll leach out of the soil as long as it can move down and out. So we have lost a little bit of calcium, we've lost a little bit of sulfur, but that's the price you pay for getting rid of the magnesium. The sum of the base saturations is now just below 80, about where you'd want it. We'd like to add back about 10 points more calcium. We'd like to lose about 10 points more magnesium. We're headed in the right direction. And now would be the time to add some gypsum, we think. Calcium and the sulfur in gypsum without the magnesium would get us back in balance. And so the landowners agreed this coming spring to put some gypsum, about 2 tons per acre, on part of the field, and then we'll be able to do a side-by-side comparison with what the gypsum helps us resolve and what we have without it. And so that will give us a side-by-side comparison. But this shows that this was the key problem. The magnesium was way too high, and we've got that moving in the right direction. Until you get that soil structure opened up so you can drain out the magnesium, you weren't going to be able to resolve that problem. It had been this way for a long time. There was adequate calcium, there was adequate sulfur. It wasn't a matter of just adding those two nutrients, as some people would suggest. If you had a soil that was open and uncompacted, that might have worked. But in this particular case, it was so tight that even though those two nutrients were present in adequate amounts, you still couldn't get rid of the magnesium until you opened up the soil. And that's what we were able to accomplish by increasing the microbial activity. And again, our approach is just one way to do it. There are others, but it does show the benefit. As far as the other parts of the soil chemistry, I didn't provide nitrogen because of the soybean rotation. It's a little hard to compare year to year. The west side of the field was continuous corn 2012 to 2014, and the nitrogen did go up by about 30%. East side had been in beans this past year, so there was less applied, and so that showed a fairly stable nitrogen amount. But in terms of potassium and phosphorus, they both went up. Phosphorus is about 2.5 times what it used to be. The potassium, which in particular is less available in the presence of high mag soils, has increased by almost 50%, and the zinc has gone up. And zinc's important for making nitrogen available. All of them are approaching adequate ranges, don't really have any problems or shortages there. As I say, we are short now on calcium and sulfur, but it's mainly the price you pay for getting rid of the mag. And so we've got that headed in the right direction, and we think the gypsum is going to help out with that. In terms of pH and things, the pH has gone down. It was a little bit high before. It's still about the 6.5 range, but when you lose both calcium and magnesium, you're going to have a drop in pH. Magnesium has almost as big, or some people say even a bigger impact on pH than calcium does. And so by reducing that mag, that makes the soil a little bit more acid. Not greatly so. We're not concerned about it, but we also don't want it to drop too much more, and so the gypsum ought to help with that. One indication of the problem in the soil is the sodium level. If sodium's a cation, and usually it starts to build up if you've got drainage issues in the soil. If water's not able to infiltrate and move in the soil, you see sodium build up in the top 4 to 8 inches, and that's what we had here. The sodium levels were really high in 2012, but by the time we opened that soil structure up with higher microbial activity, they're back down to much lower, more tolerable levels. The one thing that really surprised us was the change in organic matter on both sides of the field. We tend to see increases anytime you increase microbial activity in a soil, but not this large. This one was kind of a surprise for us, and a good surprise, of course. But we started out with about 2.5% organic matter on both sides, the east and the west side, both the clay and the clay loam sides. That's a little bit low for what you would expect on a clay soil in that particular area. And a lot of that's due to the fact that it wasn't draining well. The residue decay was hampered by the high magnesium. You had limited microbial activity, and as a result, your organic matter was lower than you would expect for that type of soil. 2 years, we don't usually see this big of a move, but we were very pleasantly surprised to see that we more or less doubled the organic matter on the west side by increasing the potential for that soil to help break down residue, and by getting rid of that magnesium that was also hampering it. And on the east side of the field, it had gone up by a full point in 2 years. Rare to see that big of a move in organic matter in that short period of time, but again, it's pointing that things are going in the right direction, and we've resolved some of those health problems with this particular site. The end result is we got a happy landowner now. The guy on the left in the blue jacket, that's my dad. And he's got his bucket and his soil probe out taking the soil samples last fall. The landowner, Steve Spring, is on the right, and he's very pleased with the outcome. In between them at their feet is the soil penetrometer inserted in the soil layer to the full depth, 27 inches. Didn't even get close to 200 pounds per square inch, so it's uncompacted at that point. And so the other good outcome that was reported to us late last fall is Steve was talking to his tenant, and the tenant said, well, something good's happening in the field. The tile's running now. And Steve said, well, gee, that's interesting. I didn't even know there was tile on the farm. When they bought it, the previous owner hadn't indicated that there was tile. Hadn't worked, probably didn't want to talk about it and make it an issue when you're selling land. It hadn't run for a long time, evidently, because the outlets in the ditch had grown over, and there was really no visual evidence of them until you got right on top of the things. But by opening up that soil structure and improving the biological activity, the water could drain from the field, reach the tile, and the tile started to work. They were running last summer for the first time in a long, long time. We were pretty confident that we could help Steve with this particular farm because we've had a lot of cases like this in the past. This was the most recent example. It's the best documented case. The only thing I wish we could have done would be to use a Solvita test or something like that to demonstrate the change in the microbial activity directly rather than measuring the outcomes that come from it. The penetrometer readings, the changes in the soil test, the fact that the tile are now running, all pretty strong signals that we've got better soil biology, better soil health in this field. But the Solvita test was not commercially available when we started, so we didn't have that benchmark reading. The next time we go through this, we will definitely do that sort of thing. But again, it's based on the observations of the landowner and the tenant, the things that matter to them. This was a big success, and as I say, it's not the first time we've done it. I had Dad dig this out of the archives yesterday. This is a picture very similar, two guys staring at a soil penetrometer shoved in the full length of the probe. This was taken in 1987, 27 years earlier. The guy on the left in the light jacket is Gene Voss. He was one of our very first customers. Farmed with his dad Herman near Morrison, Illinois. Once he retired from farming, Gene became a dealer for us, still is. He was in the office Tuesday and still around. The other guy is the farmer, the landowner in the blue jacket. That's Albert Wagner, farmed in Lee County, Illinois. Unfortunately, Albert's not with us anymore. He passed away about 10 or 12 years ago, but he was another early customer, very skeptical about the biological approach. Talked to Dad and Gene quite a while about why he would want to do this, what would happen. He said, well, in the end, he had one field, and he says, if this is going to work, I want it to work there. It was a bottom soil. It was higher clay, not a high mag situation, but it was a high cation exchange capacity. He had cation exchange capacity in that field over 40, not the highest I've heard of, but pretty high. And so it was a tight soil, again, poorly drained. Fertility was there, but not available, and residue breakdown problems, low yields. Albert said, if you can help me in that field, then you've got me sold. So they started in 1983. This is 1987, 4 years later. The compaction's gone, yields had come up. Albert was happy, and so we'd repeated this a number of times. But this is the first one. The last one I showed you with Dad and Steve was the most recent one, and we've had a lot of experience with improving soil microbiology to solve some of these troubled field issues. The other one we show a lot is this picture of the root system. This, again, not that all of our customers are gone, but this is another gentleman, Elmer Heim, that's not with us anymore, but he farmed at Lynn County, Iowa, near Coggin, near the Cedar Rapids area. Different situation. He had an upland timber soil that was not a real heavy clay, but it had been abused by overuse of anhydrous ammonia and had been moldboard plowed for years. So there was a plow sole that started at about 8 inches, went down to 18 or more, very heavily compacted, not a lot of biological life. All the root mass was at the top, yields were low. Most of the neighbors stayed away from this farm when it came up because they knew it was unproductive. Elmer jumped in, told Dad again, he was very skeptical about what they could do, but he said, if you can solve the problems on this field, that would be a tremendous improvement to me. 4 years later, I think this was 1989, they dug down 5 feet along one corn row and followed the roots 5 feet. And they were still going when they quit and decided they'd dug enough. And it just shows that there's no evidence of compaction. The roots are able to go straight down without any trouble. His yields came up. He was able to reduce his nitrogen because more nutrient was available. And so again, evidence of what improving soil biology can do to help resolve different sorts of problems in fields. The source of the trouble in these 3 cases were all different. The symptoms were very similar, and simply by increasing the biological activity, you can help resolve at least some of these problems. In conclusion, I just wanted to offer, we'll try to answer some questions, but before we do that, I just wanted to note that we're well past our best discount of the year. That's in December, and then we repeat it again in early September. But our 12% discount we'd like to offer to anybody who's sat in and braved the webinar today and listened to me drone on for a while. If you registered and attended and would be interested in trying Chandler Soil or one of our other products, whether you're a new customer or an existing one, we'd be happy to extend our usual December discount to you through the end of March for about the next 5 weeks. And as long as your name's on the registration list, we'll be happy to offer that to you. If you've got any questions, let us know. Send us email, give us a call. But beyond that, I appreciate this opportunity, and we'll see if there are any questions that we could answer.
Yeah, thank you, Doug. We are going to jump into some questions. Before we do, I did want a couple things just clarify too. You had talked about the tillage system that this field was in and what it currently is in. I think it sounded like it might have been the landlord's decision on what he wanted, or maybe you could just clarify what it was and what it is now, and the reason it's probably in the tillage system that it's in.
Well, yeah, it's rented out, and so the tillage decision is really the tenants. But okay. He's not a no-till farmer. He uses what I would call a sort of a reduced tillage approach. It's chisel plowed in the fall. I think they hit it with a disc in the spring and leave it if they can. If it needs another pass, they've taken it. But it's usually about a 2-pass system. That field, I think anybody would have been scared to try no-till on when they started because it was so poorly drained, so wet, that starting with no-till fresh out of the box would have been a real challenge for anybody. And again, it highlights it took us 3 years just to get to this point. It takes a while, whether you're using cover crops or you change tillage or you're using rotations or biological additives. It doesn't happen overnight, and this, our 2012 results showed that it was a slow start, but it takes 3 or 4 years. It was tilled. It'd be nice now that you've got the soil structure opened up and things that it could be reduced. It would be nice if cover crops could be applied. And as I say, the landlord has committed to using some gypsum to help resolve the calcium and the sulfur issues. But that's their choice. So
you see some possible other practice changes that might get introduced in here moving forward. I know the gypsum is the one thing you talked about, but I don't know if there's any discussions about any other possible changes that could come down the road.
We have talked to the landlord or the owner about cover crops, and that's something that would be nice to show. You know, the picture we had of Dad and Steve standing out there in that bean field, that ground was pretty bare last fall and hasn't had a lot of cover this winter, and so it would be nice to get that covered up, either on that side of the field or all of it, just to protect that soil resource. Now that we've got it improving, it's moving in the right direction. Um, let's protect that soil a little bit more and provide the microbes a little bit more root activity throughout the entire season to feed them. So that's something else we've talked about, and I hope we can get it done.
Yeah. Well, we do have a lot of questions. Some that were submitted ahead of time, and some during. I know we won't get to all of them, so you'll have a little bit of homework to take home with you, Doug. But I'm just going to let you go ahead and pick out the ones. You can see them all. I'm going to let you pick them out, read out the question, and go ahead and answer them. We'll get through as many as we can here yet this morning.
Sure. The first question I see, what's 16 ounces per acre cost? It's about $10 an acre. As an alternative, if you were to have put 3 ton of gypsum on this field from the start, our local gypsum source is about $40 an acre applied. I know some people get it less. In fact, I talked to a guy the other day that's buying it for $20 an acre applied, but in our area it's $40. So that would have cost $120 up front. Our double treatments of soil cost $60 an acre across the 3 years. So it is cost effective. Let's see, Brock wants to know, what is high mag? It does depend on the soil type. Usually high magnesium is anything above about 20% base saturation. The heavier the soil, that threshold can be a little bit higher, but typically you want the magnesium somewhere in the 12 to 20% range. Once it gets above 20, you get the problems. This field was 30 to 37, so it was well out of range. Let's see. Oh, Les is in here. He wasn't able to get his soil on in the fall, and we have people that do both fall or spring. We got people putting it in the row. In fact, we've done 2 years of trials in Western Illinois at a field near Nauvoo where we put the soil just in the row rather than broadcasting it, because a lot of guys find that's more convenient to put it on with the planter rather than trying to get a chemical applicator or somebody else to spray it for them. And we've had just as good a yield with in-row applications at the 8-ounce rate. And so you get the cost down to about $5 per acre and you don't lose any yield. The only difference we've noticed is we've taken soil penetrometer readings, and between the rows where it's not applied, there's a little bit more evidence of compaction. In the row, broadcast and banded, you got 18 inches of uncompacted soil in this particular field. In the center of the row where it's been broadcast, it's again 18 inches. It's worked down about 8 inches a year in 2 years. Where it's been banded, there's 10 inches of uncompacted soil. Doesn't really matter as much in the middle of the row because you don't have as many microbes there, but that's about the only difference we've noticed in doing that. So you could put it on the spring, you can put it on with the planter. We've got some people that put it on post-emergence. If they're spraying soybeans, for example, with Roundup, they'll put soil in because at that point the beans aren't canopied and most of the product's going to get on the soil anyway. So anytime you can get it on the soil, it'll work. Let's see, what if you're dealing with a heavy clay gumbo or heavy clay subsoil? We've had success with gumbos and even heavy clay subsoils. We've got a father and 2 brothers that farm near Cedar Rapids. They got a dairy operation. And in their area, there's a band of clay that runs about 5 feet down. They call it a blue clay. And whenever the tiling contractors go into that, they got to put an extra tractor on their tiling rig because it pulls so hard. And so when they cut through that, they've got a lot of trouble. And these guys have been using soil. They're also into rotations and other things that promote soil biology. But they've been at it about 8 or 10 years now, and the tiling contractor said, I don't know what you guys did to your field, but when they tiled this field 2 years ago, they didn't have to use any heavier equipment. They didn't have to put on the extra tractor to get the tiling plow through the soil. He said, I just cut through it like it was butter. That was the comment. Um, and it worked down 5 feet over that time. It took a while. They were at it about 10 years, but it still does work into the subsoil. And so even a heavy clay gumbo, whether it's at the surface or subsoil, can be improved. It just takes a while to do so. The microbes will work down. Let's see, we talked about cost per acre. Yield wise, it's the best comparison would be 2013 to 14. 2012 was a drought year, so that wouldn't be fair. But 2013 and 14 were pretty similar years in this particular area. Cool, wet spring, things got off to a late start. Pretty good summer, and then again a little wet in the fall, so it was late harvest. But the corn yields, from what we understand, it increased about 40 bushel, 2013 to 14, and so it was similar tillage, similar fertility. Really, the only thing that changed was the nature of that soil. The bean yield, I think, was up somewhere 10 to 15 bushel. That's about the best information we got. I didn't provide the yield information because that really belongs to the tenant, but from what we understand, the yields have really jumped, and there are a lot fewer other problems, like with the drainage improving, they can get into it faster, soil warms faster, so the emergence has been better. Let's see, impact on soybean inoculant. Anything that helps the soil biology is going to help the inoculants work better. And in fact, we've talked to people that, whether they're using reduced tillage and cover crops or they're using products like ours, they feel they're able to get away without bean inoculants as long as they're rotating and getting beans in those fields about every third to fourth year. There's enough native microbes, enough native bacteria there to help the beans emerge and form nodules without using an inoculant. I don't recommend that in general, but the folks that have been working with it have told us that they've been able to reduce or remove inoculants if they're in a situation where they're rotating and they're getting beans in there about every third year or so, and increasing the biological activity in those fields helps with that. Yeah, Dan says was commercial lab. Yeah, the counts were done at it's now Louisiana. It's now University of Louisiana at Monroe. The school was under a different name, but it was a university lab that was done that did those counts in the field. We tend not to do much university testing anymore because of its expense, and we find that most of the producers really want to know how it works in the field, not in a lab or a greenhouse or some test site. So we use on-farm tests. We also use some private research farms with people that we can trust and that are reliable, and not rely so much on the universities anymore because of the expense.
Let's go about 2 more minutes yet if we could here. So.
Let's see. Robert wants to know about ag chemicals that inhibit soil life. That's a question that'll get a lot of response, whether you're talking with a no-till crowd or others. I've recently been interacting with some folks by email and talking about Roundup. That's one that tends to get a lot of attention. It seems to us that it's overuse of the ag chemicals, not regular routine, sort of labeled use, but especially in southern areas where they're having to apply treatments, 8, 10, 12 times a season, or, they're going at especially high rates, whether it's glyphosate or something else, it seems to be those repeated high level treatments. And there are other things. There's 0060 potassium chloride is a good source of potassium, but it's the chloride part that has caused trouble. We've had customers that applied over 300 pounds a year, multiple years in a row, trying to build their potash levels in their soil, and at the same time you're adding that chloride in there, and that inhibits microbial activity. And so, it's not even just ag chemicals, but some fertilizers will cause trouble. You'll almost always get a fight when you talk about anhydrous ammonia. I mentioned the case in Coggan, Iowa. That had been well over applied with anhydrous for many years. Anhydrous seems to affect all the microbial populations. The bacteria come back pretty fast, so I don't think it has much long-term effect on bacteria, but it seems to have, based on the studies I've seen, a bigger impact on the fungal species. They take longer to regrow and reestablish themselves. And since the fungal species are especially important for residue decay, that's where you see problems with poor residue decay in fields that have been treated with high levels of anhydrous. So it's not that anhydrous is bad, but overuse can have effect on certain parts of your soil biology and soil health that can, over time, build up into some real problems.
Might be good to even talk about. There's a question about, we're talking about herbicides. Can you apply them with herbicides, or what typically might you apply your product with that you can carry along with? So.
Yeah, the Chandler soil can be applied with just about any other chemical or liquid fertilizer product. We've got people put it in starter fertilizer, liquid 28, liquid 32, just about any herbicide. And so if you're broadcasting, burn down chemicals in the fall, you're putting on some pre-plant stuff early in the spring, post-emergence, as long as the crop's not canopied. The only recommendation we make is that you put the soil in the tank last. You get the chemicals diluted first. There are a couple of herbicides that don't interact well with fertilizers that are in suspension. The micronutrients in Chandler soil are in suspension. They're in low concentration, generally less than 1%. So as long as the herbicide's diluted, you don't get that problem. Anytime we've had a problem is where somebody's adding the soil at the same time they're adding the herbicide. They get in a hurry, and so the herbicide meets the soil when it's undiluted, and it can cause a little glob formulation in the tank and plug some filters. But as long as the chemicals are diluted first, we haven't had any problem. And it's only a few herbicides that do that. The two that come to mind are dry simazine, not the liquid form, but the dry form, and sharpen, which some people use for dandelions and some other particular problems. Glyphosate's not a problem. Most of the other major broadleaf and grass herbicides aren't a problem. You don't need a special trip. You don't have to apply it by itself. As long as you follow that one recommendation, things generally work out.
Right. Good. Well, we're going to make a wrap on right here, and there's a lot of other questions that Doug didn't get to. I know we're going to send those home with him, and any that definitely feels qualified that he can answer and give an opinion on, he'll definitely answer those, and we'll make those available with the webinar replay when it goes up there. So I just want to let you know that when you log off here today, you're going to receive a questionnaire to complete. It's a very simple one, easy one to complete, small number of questions, and it really helps us determine the value of today's webinar and also with planning for future ones. And again, we did mention that we will be making available via email to you today a replay of today's webinar in the event you'd like to go back and review the entire presentation or just some parts of it. And that'll be going up on our No-Till Farmer website shortly, probably within the next 24 to 48 hours. And there's also an archive section up there of past webinars that you can go back and listen to as well. And again, as we mentioned, we're going to send these other questions back with Doug. He'll answer as many of those as he can, and we'll make those available, the answers to as well. So I do want to thank Doug again for leading this discussion, and thank Midwest Biotech for sponsoring this webinar on reclaiming troubled fields. And I want to give a shout out to our producer, Cole Vandermouse, for making things work well today. Hope you guys are looking forward to March. I know I am, and hoping for some warmer weather. In the meantime, until our next webinar, wish you all the best, and so long. Have a great day. Bye-bye.